Dear friends, Mass Aspirants is a collective of mathematics students, research scholars, and teachers across India, initiated by myself in 2017. And we used to arrange online problem solving sessions and online test series to help the students who prepare for different national level competitive examinations. As a part of that, 3 exclusive online problem discussion sessions focusing on the forthcoming TIFR GS 2023 examination. The first of that series was held on the last Sunday, and today now we have the second session, and we have Mr. Jayakumar Ravindran is with us to engage today's session. Mr. Jayakumar is currently a senior research fellow at IMSc Chennai. Jayakumar did his MSc from University of Madras and qualified CSPR JRF with All India rank 27. And Jay is also a recipient of NBHM fellowship. I am very happy to introduce Jayakumar to all of you. I welcome everyone to this program, and I would like to express my sincere thanks and gratitude to Jay for joining with us. I hope that today's session will be really helpful for all those who are seriously preparing for competitive examinations. I welcome everyone to this program. Welcome, Jay.
I'm not outsider, first of all. I already gave one talk, but I was here. I'm started here like 2019. From 19, I'm started here. I came to know about this thing from few friends. I'm really interested on this. That's why I voluntarily came to Vinod sir and I said that I will give a talk, and that talk went really well. So when he asked me to give another talk, I was like very happy, to continuous in the way. And I love algebra, so he just asked me in algebra itself. So it's very pleasurable for me. So in this talk, what I'm going to do actually, we are focusing on TFR. I mean TFR GS exam. So nearly some 15 questions I had included that, but still we can do something more than that also. So we will start up by warm-upping the things. Many of you know already, right? Some of the things. So we start warm-upping thing. Most of them are without proof, but the idea I will convey very clearly. Especially this section is standard by the pillar of Silos theorem. You can do much more than a TFR. I'm saying that you can do really much more than a TFR. Overall, this Silos theorem portion will cover all this competitive exam, but we still focus on TFR. I had included relevant questions. I'm going to say that most of the questions in TFR, I'm going to give an idea, not really going to solve, but I'm sure after this class, whatever the questions I had included from that, you can able to solve, right? As a student, suppose you are preparing for exams like TIFR or NBHM, you must have come across few standard results. I just included those standard results for a warm-up, right? So for example, this result. So this result, number of generator of the cyclic probe is nothing but a Pn. Just Pn, right? So this kind of results are very pretty standard and normal. You are like most of them are aware of this thing. So it's like, for example, this, the formula is n into 1 minus P1, 1 minus 1 by Pk, where n equal to P1 alpha 1, Pk alpha k. This alpha is greater than equal to 0. So whenever this kind of things are already. Few questions I have seen today in a TFR exam relevant to this. That's why I wanted to start with this thing. I already did one cyclic group relevant thing. You can find this kind of idea. So, and there is another reason why I had included this as a first result. First of all, this is kind of relevant to number 3. The main topic of today is about Silos theorem, and I'm not going towards the proof. Okay, right? So I'm not going towards the proof. Since I'm not going towards the proof, we are going to explain the statement. And I just wanted to say that the quantity, the number, it's going to control the quality. I will also give you a few things that what happens to the upcoming exam after this, right? You have to face interview and all those things. I also give a small hint about the interviews and I will tell while it's coming. Okay. Okay. Then the second result is index to subgroups are normal, right? We know this index to subgroups are normal. Okay. The third result that Z has countably infinite subgroups. In fact, the n z's are the subgroup of Z where n belongs to natural number union 0. And it was a part of my PhD interview question. First question they asked, and in there they asked me to prove this. It's a part of my PhD interview in IMSc. Okay, this also we know. Okay. And so whenever we are going to do some relevant question to that, that's why I'm spending some time on this. Any group that contains a Z as a copy has infinitely many subgroups, right? Yes. The number of homomorphisms between this and this is always GCD. It will take some time to explain these things, but just I'm sure that most of you are who's going to prepare for a NBHM, CSIR, and a TIFR exam, they must have known these things. Okay, just wanted to warm up. Okay, all subgroup of a cyclic group is cyclic, but the converse is not true. In the both infinite and a finite level, in fact, in CMI, whoever come for MSc, they sometimes they ask these questions. Okay, the one for finite thing, this is the reason. S3 is the reason. All the proper subgroups of S3 in a converse way, what should I put? All the proper subgroup of S3 are cyclic, but not S3. Okay, subgroups of S3 is cyclic because it's order 2. Lagrange's theorem says that it's order 1, order 2, or order 3. But S3 not even Abelian. Okay. Yeah. Okay. So I had to put some relevant question. For example, this is relevant to the, there is an MCQ question from TFR. So the answer is 560. And I already gave you the, the formula one can connect. And just wanted to show you these collective results are corresponding to this inclusion. Today, my major idea is not going towards this, but just wanted to, as I mentioned, just warm up the things. Okay. Second, a cycle. Okay, so true or false? Every subgroup of 72 out of 48, I mean, the group of out of 48, this is index to idea. So it is true because it's index to subgroup 74. 148 by 74 is just 2. What is the index actually? H is a subset of G, then H is defined as order of G by order of H as far as finite. So I am assuming finite, okay? But infinite case also one can do, but for us now it's finite. So this is our second result. Now let's go to the next step. How many proper subgroup does this have? I mentioned that integer has many subgroups, infinitely many. So we can throw integers here, like n goes to r, maybe let me put z goes to z comma 0. So there is a copy of integers here. Since integer itself has a lot of many infinite subgroup, so these are infinite subgroup. So the one of the answer, I didn't put it here, but one of the answers says infinite. All other answers are saying summons 2, 3 like that numbers, but one of the other saying that it is infinite. Okay. Okay, the number of homomorphisms from here to here. So I should have put it here 29. So Z20 to Z29. We know GCD of 20 and 29. These are pretty, simple and small questions that you can expect. As far as I gone through TFR question paper from 2010 up to now, there are certain questions, it's easy. They also follow some kind of pattern that they wanted to give a motivation and want people, I mean, the student to be a little more, innovative as well as intelligent. Intelligent people go through all the question paper. Always I said to my student, go through all the question paper, even if you know some of the question. That means let's say it's difficult. Don't stuck. You may have a good, correct answers, But don't stuck at there. Go ahead and see, do the easy questions. Once you do the easy questions where you are so comfortable, it's easy to answer, you will get the momentum. Once the momentum is coming, it happens. That's what happened when I go through. There are certain questions. These are the easy questions I have picked up out of the TFR question paper, last 10-year question paper. Okay. Okay. Then again, true or false? If every proper subgroup of an infinite group is cyclic, then G is cyclic. This is also not true. This is false. The answer is for this 2 power n, where x belongs to integer, n belongs to natural number. So this is a set. One need to really check. This is actually inside the Q plus. Under addition, one need to check this is a group, and it takes some time. Okay. But this kind of example make you really rich. Okay. The richness of in mathematics in certain way is measured how many examples you know and how well you know. It's like you without any hesitation, can you able to do it? Okay. It depends on that. Okay. Right. So far, so good. These are just warm-up question, and just wanted to say TFR contains such easy questions. Every set of question paper contains at least one easy questions like that, where you are just use just temperament, just control your temperament, use it, and you can attack it. Out of 5-6 questions from Aspirants, 1 or 2 questions you can easily solve. Okay. Now I just wanted to go deeply into our talk. Today, the main topic is about the Silas theorem. At the end of the section, I had included 4 Silas theorem questions from TFR, then few Silas theorem questions from other, and which are so important, which are really, really important. And as I said, we are not going to understand the we are going to understand the statement, but not the proof. Proof is so difficult. It uses a very typical group action techniques. But TFR requires, the statement. Statements are really, if you start understanding. There are 3 theorems. 1, 2, 3. First theorem, second theorem, and third theorem. First theorem called existence theorem. Okay, we have to set up something, but let me say, first theorem is called existence theorem. Second theorem called the relationship theorem. Let me call E existence relationship theorem. Third is called counting idea or counting theorem. Okay. In this talk, I'm going to introduce 2 beautiful techniques. Actually, there are 4 techniques we can use. But once if you are going into the MSc or finally, first year of PhD, you will come to know the 2 things, two methods. And the third method required a group action. But without even group action, 2 methods, direct method and the counting method can be demonstrated. That's what I'm going to do. I hope if you start listening from now itself, you can be able to understand. Hello? What happened?
Again, or
I didn't understand what you were saying. Can you just little loud so?
explain
Okay.
This bracket counting again.
Counting. Okay. So I didn't. There are 3 theorems. What I'm trying to say is actually, in this 3 theorem, there are 2 techniques. 2 techniques. Okay. One is direct. Another one is counting. These 2 things you are going to learn today. And using these 2 things, how one can solve TFR questions at the end of the session. And also included something about infinite thing. Depends on the time I will go through. Depends on the time I will go through, right? So yes, I'm audible now. I'm going to set up the thing. I'm audible clearly and visible thing. Everything is visible?
Yeah, it's okay. Everything is fine, Jay.
Yes, sir. Yeah. So this is a beautiful thing. Number theory is used. I like this. P power alpha. So let me put prime power alpha double divides this. It means P power alpha divides n. But p power alpha plus 1 does not divide n. It means you can write n as p power alpha m because of this, but the GCD between m and p is 1. In a way, you are extracting maximum power from here. Maximum power. Okay. So the converse of Lagrange's theorem is not true. Even in A12, not A12, A4, we know that it is order 12, but it has no subgroup of order 6. But 6 perfectly divide 12. So the converse of Lagrange's theorem is not true. So that's why the power of prime numbers are started coming out. Silo really asked the question, how can I get something like similar to, converse of Lagrange theorem? Maybe it's not true for general divisor, but already Cauchy had proved for abelian group, if it is prime divides n, then one can come back. So if it is true for prime, how far that can go? That's how Silo got this. So the movement you see this is a number theoretical notation, or regular notations are this. When you see that, you are taking maximum prime out of this n, the maximum prime. So that maximum is matter. That's why the Silo things are called maximal P subgroups. Okay, fine. So this is a setting up. I'm going to start with a G whose order is n. This is setting, and which is like p power alpha into m. The maximum power I taken out. Okay. So bear with me for few minutes maybe. We have to go through the 3 things. Then I will demonstrate how one can work practically. I also included a very nice table at the end so that you can able to answer yourself and see by confirming that you understood this lecture. Okay, that confirmation also will be done at the end. Okay. So the first is 0. I set it up. This is my n, and this is a thing. The first theorem called existence theorem. Okay, that is, suppose p power alpha double divides n, where that is this, then there exists a subgroup G such that the order of G is p power alpha. Corresponding to the maximal divisor, prime divisor, there is a subgroup, the existence, that's it. Like for example, suppose I have a, let's say 12, then 2 square into 3. Corresponding to 2 square, that means 4, there is a subgroup in A4. Or any other group of order 12. Corresponding to 3, there is a subgroup. This just assures that the existence of subgroup, nothing more, nothing less. Okay, it just ensures that there exists a subgroup of this kind. Okay, suppose what about 105? Suppose we are 105 is 3 into 5 into 7. This theorem just telling corresponding to 3, there is a 3 order subgroup. This theorem tells us corresponding to 2, there is a 5 order subgroup. Corresponding to 2, 7 order subgroup. Okay. But here remember that this is 2 square, not just 2. This is not saying there is a corresponding subgroup of order 2. That is kind of an implicit implication, but it's saying that corresponding subgroup of order 4. If you go for like 96, 2 power 5 into 3, there will be a corresponding subgroup of 32, not 2. Remember that need to be taken care. So this just theorem, how to remember that? This is just an existence theorem. Okay. Not much useful, but existence is matter, right? Lot in mathematicians care about existence lot. Okay. Such a subgroup is called p-Silo subgroup or Silo p subgroup. So I prefer to call p-Silo subgroup the maximal one. Okay, fix in your mind the maximal one. Although this is like a rough word or some like a informal word, but I like to keep it so that you can able to proceed towards this. Okay, maximal, but I didn't include in this notes. Okay. So the second theorem called the conjugacy relation. What is this? What is the meaning of conjugacy relation? So let me read it first. any P subgroup of G contained in P cellular subgroup, and any two P cellular subgroups are conjugate. Okay, what does it mean really? What kind of relation this? Okay. So in linear algebra, you know, right? Suppose that
Sir, not audible. Not
Voice
audible.
is not coming, sir.
I'm audible now.
Yes. Yes, sir.
Okay. So this W1, W2, Wk, then Vk plus 1 up to Vn. We can extend. How we can extend? First we take W. This is like a V. The big one is V. Then I take something outside. Then span it. Something outside. Then span it. So slowly I'm exhausting. Exactly something similar is happening here. Here, actually what happened, I start with, let's say this is my group. And here I have a P cellular subgroup. Okay. But instead of starting with a P cellular subgroup, I start with a P group. What is P group? The order is just P power beta. It's a single prime. The order is a power of single prime. Single prime and power, right? So I start with a P group. This is, let's say, P group. Then I slowly, exactly like that, I can construct something like this, slowly exhaust by putting other P group element outside. In a way. But at some point of time, this should be like a terminator, right? Just because of finiteness. All the groups I'm dealing with up to now is finite, unless the last section. So that's how. So every P group, there exists a P cellular subgroup. So it's like contained in that. There is no like, you know, a P group is there, semi-conducted by one P cellular subgroup, another P cellular. It's not like that. It's completely contained in one P cellular subgroup. There are possible. So there is a one P cellular subgroup here, another P cellular subgroup here. The P group may be here in the intersection. That is possible. Very much possible. But it's not like off of somewhere and somewhere. Either if you see from relatively this P group contained completely here. And the very important thing, very important thing, let's say I have a P cellular subgroup H1 and H2. There is a relation. What is the relation? H2 GH1. Sorry. Conjugate. That is, this theorem telling us catch one P cellular subgroup. Okay. This theorem telling us catch one P cellular subgroup. Let's say I catched one P cellular subgroup. Then put G here, G here, inverse here, conjugate. These are called conjugate subgroup. Then run. You will catch all of them. So all of them are linked by conjugation. In a way, they are connected through the conjugation relation. Like I'm saying again, get one P cellular subgroup. Just put G and G inverse pre and post multiplication. Then you will get all the P cellular subgroup. So they are conjugate to each other. They're related. They're connected by getting one P cellular subgroup is enough. Okay. So if we have time, tell me in the final moment, I will just talk about, G ln of FQ. This theorem is kind of very much related to that. But this is like very advanced thing. But people are asking these questions in the interviews. This happens in a IMS interview. Okay. Anyway, so I will talk about this later if we have time. So what I'm trying to say, this theorem giving an idea that get only one, then go here, collect all of them. You can collect
Sir,
all of them.
hello.
Yes.
Hello, sir. I want to say, so all P cellular subgroup contains same equivalence class.
What equivalence class? With respect to what relation?
So I mean, I am saying that since all p-silo subgroups are conjugate,
Right.
so therefore from here they contain same class.
Now what you are trying to say actually, you start with a G, putting the equivalence class under conjugation. Then after this explanation, you are saying that all the silo p subgroups are belongs to one class. That's what you are saying, right?
Yes, sir. Yes, sir.
Yes. Yeah. It's worth to note, but it's not kind of necessary right now. I did it because of this theorem. This is the one of the very important. Let us spend few time. Connection from quantity and the quality. Connection between the quantity. Quantity means literally counting. So quality means whatever we did. So this is a quality, right? G inverse equal to H for every G. This means normal. We say a subgroup is normal if this satisfies this condition, right? G, putting G here, H here, G inverse here, and I will get again H. This is the kind of quality. It depends on very much depends on the nature of the group, right? The conjugation, I mean the binary operation, all those things. It's very much depends on that, right? So this corollary says that see that unique is means only one quantity. There is a quantity and the quality condition. This says that a p-silo subgroup is normal if and only if it is unique. That is, as I said before, let me erase this. As I said before, you catch one, then put G here, then you will get all of them by changing the G. What if it's unique? Suppose unique. Then you will get only one. You don't get anything. You will get again and again, only one. So this is for every G. So unique implies normal. This implies normal. But normal, by definition of normality of H, normal implies, suppose the normal implies this, and that means I catch one, I put G and I put G inverse, I'm looking for other, because of normality, H only I will get. So that means it is unique. Now this translation is very important. This is achievement. This is one of the greatest achievement. Catching the normality through the quantity. So there is a quantity quality connection frame. So this is going to play a vital role. That's why I'm spending a lot of time. Okay. And there is a beautiful thing in if you go through 𝕬𝕧 book, it's a beautiful thing. They discuss about group of order, middle order, group of higher order. They're trying to classify all those things, right? So before even classifying, we have to understand what is simplicity. That is also I talked about here. Okay. So let me go through the next statement. That's going to, okay. This statement is very good. This is a very good theorem. And this is a very nice corollary establishing the quality quantity connections. But where can I count? How can I count? Is there any way to count? And that's about the third theorem. This third theorem saying something very beautiful. That is, let's take NP. NP be a number of p-silo subgroup, the number of p-silo subgroup in a group P. Then this satisfying this condition. That is NP minus 1. P divides NP minus 1. And remember that N written like P power alpha and M. And this NP, the number, the M divides. In Galilean book, you will say like that, this theorem says much more than that. It divides M. So divides N, automatically divides N. In Galilean book, he directly puts N. He talked about this equation. It talked about this, but instead of M, we put N. Of course, in our version, this is a version taken from Michael Artin. This says that this divides this, N says divides this, but much more than this, right? Much more than this. This is much important. So this gives an idea, not completely how to count, but it's giving a starting point. We will see some of the typical application. Then we will go through what happens that, right? Okay. This counting theorem giving how to proceed towards the uniqueness and the quality quantity connections are made. Okay. So this is done. So now what the existence theorem is like, it's a redundant. Redundant in the sense it's assumed. Once it exists, yeah, it exists. Somebody showed. So we don't care about much. We just use like a numbers. The third theorem we have to use and see the connection. Okay. Okay. This is an example. This example almost discussed by many people. Almost all the books are discussing about this example 15. There are some reason for that. Okay. Here I did not put, but I'm going to tell you what are the reasons. First of all, you start asking yourself. Start from 2, 2, 3, 4, 5, 6, 7, 8, 9. The question is, okay, the question is, first composite group always cyclic. That means I want a group which is composite, first of all, but it's always cyclic. And this is the thing. This is the first composite order group. Okay, let me put order here. Order. Directly or indirectly, people ask a lot of questions relevant to this in many exams, including TIFR, NBHM, right? This question is important. Once if you start understanding this, you can go for the advanced version. Okay. So I worked out this question here. How to do it? So far, what we have understood, we have understand the existence theorem. Second, we have understand the quality quantity connection. That is what more important rather than theorem, the corollary. Third, the unique means normal, normal means unique. Fourth, okay, the fourth thing, the very important fourth thing is, the third thing is how to count. Now I started working out. Slowly I will demonstrate how to work out. First, let us do this. So I start from n equal to 15. Then I return 3 into 5. I know with respect to 3, there is a subgroup. I know with respect to 5, there is a subgroup by first theorem. But we don't care much. We are like to use it without even saying further words. Okay. Now, let me call N3 like number of 3 silo. Okay. Number of 3 silo. Then N3 divides the remaining. Forgot about this guy. The remaining, this divisible by 5. N3 is dividing the 5. So that means because of this prime, I will get 1 or 5. That's what I written here. But also N3 satisfies this equation, right? P divides this. That means 3 divides this. What is the equation? N3 congruent to 1 mod 3. That means this. 1 is always possible. 1 minus 1 is 0. Any number divides 0. It's meaningful. This is meaningful. That's okay. But what about 5? 5 minus 1. 5 minus 1 is 4. 3 does not divide 4. So that is not possible. So that's why it is this. So again, I am telling, whenever you wanted to do silo analysis, that's what we are going to do. Many questions. Whenever silo analysis, first split the thing into primes, split the thing into prime, and always write in a ascending order, like 3, 5. Okay. For example, 96. I will not put like this. I will put 2 power 5 into 3. This is the kind of a custom practice we are doing. Then one by one we can discuss. So forget about 5. 5 is like a remaining to us. Now with respect to 3, I started understanding. What is the understanding? With respect to 3, let us call N3 be a 3 silo subgroup. Then N3, whatever the remaining 5, that will be divided by the second equation. See the equation. Then checking with that. Pinpointly it says it's 1. So let us call the subgroup, say H, the subgroup relevant to 3, say H. Then this says that H is normal. H is normal. So let us now change the perspective. Let us make, this is a very important thing, 5, the next one. Okay. So for me, 5, I'm going for 5 Euler subgroup. Then n5 is the number of 5 Euler subgroup. This n equal to 3 into 5. 5 is the main thing. Then I have to see the remaining. Remaining is 3. And third-Euler's theorem says that, again, let us go through. Third-Euler's theorem says that number of p Euler subgroups, here it will be divided by this m, the remaining. Whatever the remaining, n equal to p power alpha and m, whatever the remaining. Then it satisfies this equation. Okay. Good. So whatever the remaining is the 3 divisible. So 3 is a prime. I got only 1 or 3. And I know this equation need to be satisfied. Of course, 1 is always going to satisfy, but not 3. 3 minus 1 not divisible by 5. In fact, it's very low. So there is only 1. So that means we call the group K relevant to 5, call K, then this K is normal. So you see, without even knowing the nature of the group, how the operation is defined, just by knowing the number, the order, the number controls many things. Whatever the, however the definition of composition law, I mean the binary operation, doesn't matter at all. It matters nothing. As long as the set is 15, I mean the group order is 15, there are 2 subgroups, it's going to be normal, one relevant to 3, one relevant to 5. It's a good thing. So later on, if you know a little bit about the structures, that means internal direct product, one can easily say that this is going to be cyclic. Maybe I will talk that about that alone in maybe another talk, because it's required a lot of things. How to decompose the thing, like semi-direct product and internal direct product, external direct product, all these things maybe I will gather and I will give maybe one lecture about that, 1 or 2 lecture about that. But right now we are happy. At least this example tells us what to do. Let us go for little abstract. Okay, what is the little abstract? Let's go for PQ. Like this example 3 into 5, it's let's say P and Q, right? Where P less than Q, both are prime. So let me go through. So in school level, we understand the arithmetic equation, right? The classes go higher and higher. We started understanding algebraic equation, where arithmetic slowly turn into variables. So that's what I'm doing. Same thing. We understood about 15. Let us try for this. Okay. So now what I'm doing, I'm taking n equal to PQ, where P less than Q, both are prime. Okay, both are prime. With respect to NP, number of P Euler subgroup, that will satisfy the remaining one. P is so important to me, Q is the remaining one. That implies it will be 1 R Q, then NQ congruent to 1 mod P. That is 1 mod P. That is, what is that? NQ minus 1. But this is, we cannot say like last thing, no? Like last thing we cannot say. For example, take n equal to 21. 3 into 7. N3 divides 7. So I have a possibility 1 or 7. 1 is always possible, I know, but 7 is also possible. 3 divides 7, that is, the possibility for N3 can be 7 also. I cannot say. In the case of 15, I can say. In the case of 21, I'm not sure. I don't know. I cannot say. So this is maybe possible. Maybe possible. Some of you may wonder what we are doing. This is called the silo analysis. What is silo analysis? Let us understand. The silo analysis, first, the group order is given. You have to split into the primes. Then each and individual prime, you have to do the silo analysis. That means using the 2 equation, what are the conclusion are you are getting, arriving? That is called the silo analysis. Let us try with, NQ. NP is not working. So I like to try with the NQ. Since NP is not, I'm not getting, unique. May be possible, may not be unique. Getting unique. Now for me, the qth one is important. That means NQ. NQ will divide the remaining, the P. I have 1 RP. Also, NQ congruent to 1 mod Q. That is P minus 1. Sorry. Whether this is a question. But remember that P itself less. P minus 1 even less. This is not possible. That is NQ equal to P. Not possible. That means NQ always 1. That implies unique. That is normal. At least in the case of PQ, we are getting one thing is normal, okay? And this is why direct product and semi-direct product comes into the picture to understand more about the structure of the group, okay? That will be little more than what we are planning now, okay? So leave it. So with respect to this understanding, so here I have mentioned everything. With respect to this understanding, we can make following things. I already discussed. I discussed n equal to 21. But you may ask me, can you give me a group of 21? That is pretty difficult. That is pretty difficult. In fact, it's require a little bit of semi-direct product abstractly. Michael Artin in his book, he talked about the group of 21 using matrices. Okay, you can check. But for us, let me keep it very small, simple. Look at S3. S3 order. S3 or D23, whatever. 2 into 3. This is P. This is Q. Okay, P, Q. Also, P divides Q minus 1. That is 2 divides 3 minus 1. And with respect to diagonal, I make this. Okay. 1 R square. Yes. RS SR. S square R cube equal to 1. SRS equal to R square. This is a standard thing, okay? I'm assuming the audience is preparing for a TIFR exam, right? So since you are preparing for TIFR exams, you must know this kind of example, very standard example, like cyclic groups. The next level of the next group immediate to read is actually diagonal groups. After 4, okay, I'm giving a hint now. After 4, every even order, like, after 4, 6, 8, 10, 12, all the even number having one non-abelian group corresponding to that number, which is diagonal, okay? So remember, this is very important. After 4, of course, 4 is 2 square. After 4, everything having a one group corresponding to that number, which is not abelian. So you can check it. You can check it actually. With respect to silo, 2 is the maximal number. With respect to 2, yes. 1, yes. R, SR. 1 SR. These 3 groups are there. These 3 groups are cyclic. Cyclic, of course. Order 2, not unique. So we studied, the uniqueness implies the normality. Normality implies unique. Since these are not unique, this cannot be normal. One can check, go and check. This is very hard. In fact, slightly hard to check which something is normal or not normal. Sometimes Euler's theorem indirectly help to say not normal. You have to provide in that order. Suppose we are getting a group and we want to check it's very normal or not. Suppose it's maximal, you can go for a Euler's theorem. So it works in that way. I really didn't check, okay? But I'm saying that it is 3, it cannot be normal because normal implies unique, unique implies normality. Fine. That's what I written here. Okay. So with respect to this understanding, we can make this thing. I am sure that many of you are at least in the coaching center level, you must have heard PQ. PQ theorem, right? PQ prime, P less than Q, and P does not divide Q minus 1. Okay, P does not divide Q minus 1. If this is the condition, then G is cyclic. Many coaching institutes or many other places, they give these things, right? So they used to give these things. But what we are doing actually, we are not ready because I didn't teach you or I didn't tell you the idea about internal direct products. So I just keep very simple, normality, the bigger one, the corresponding to Q. Whenever there is a PQ where P less than Q and does not divide, P does not divide Q minus 1. I wanted to say like this, sorry. Q minus 1. Then we have a silo subgroup which are unique. Okay. So we can make this theorem, right? Now I'm getting into the main topic. When I was an MSc student, I gave exam in IIT Madras. I come to know this thing, okay? For second level MSc, second level exam for PhD, I did not heard many things about simple group. There's something about simple group I know, but not much. I never know that that is going to be so much important, okay? If you really understand simple group, you will not have a very much difficulty to understand this ideals and others, okay? Okay, let me tell you what is simple group. The definition is so precise. We have a professor named K.N. Raghavan. Let me put K.N. A very good professor. He always stressed this point. He, in fact, personally told me the better definition is this. A group said to be simple if it has exactly two normal subgroup. You can actually relate to other subject. For example, a ring said to be simple, it has exactly two double-sided ideal. Okay, for this M1 of F, these are such a rings. It has exactly double-sided ring, two double-sided ideal, not more than that. It has many left-side ideal, many right-side ideal depending on the N, but it exactly has two-sided ideals, which is trivial and wholesale. Also, you can relate towards the topology. A set is said to be connected. It has two copulent set, exactly two copulent set. One is empty, another one itself. There is nothing between them. Okay. But what we are interested in the talk, to understand not simple. If the group is not simple, that means it's kind of a breakable. I'm using a rough and like informal words. Okay. So in a way, something is not simple, means it is breakable. We can break and make it into simplest simple structure. In another words, simple groups are the building blocks of group theory. Simple, every group sort of can be decomposed into simple group, especially finite groups. Every finite group can be decomposed into simple group. In a way, simple groups place like silos. The P primes. You can understand in the way. So that's why people really likes to understand simple group, first of all. Secondly, in order to construct a different group, simple groups are going to be very much helpful. And in a way, simple groups are like a connected subsets. If you know a little bit of a very good continuous functions idea, you can understand that the continuity on the connected subset matter rather than the whole. Similarly, it happens. The homomorphism behaves very nicely towards the simple groups. Okay, simple subgroups. So that's why we are interested in understanding the simple. And one way to understand the simple via negativa. What is via negativa? People who attended the last talk may understand this word from me, via negativa. It's very, very, very like much used by Buddhists. Okay, via negativa means in order to understand this. Yes, sir.
Hello, sir.
Yeah.
Sir, would you explain the connection between continuity and simple group?
No, there is an analogy, not exactly connected. I'm saying that suppose you have a topological space this is a connected subgroups, and the continuous function behaves very differently here. For example, let's say even take 0, 1 union 5, 7 and define f to be like 1 here. Define 7 here. This is a perfectly differentiable function. Okay, and f dash is 0. In fact, if you go for that, f dash is identically 0. But you still cannot say like that f is constant because of this. This is a perfectly differentiable function. F dash is like identically 0. It is may not, but the function you cannot say like, you know, there's a theorem. It works for continuity with respect to the continuity. So the connector subsets are the building blocks, in a way, building blocks. That's why people go for in the complex analysis, always people restrict their attention to domain, open and connected, because they wanted to talk about the differentiability in a nicer format. That's why they completely shift towards the domain. That's what the real idea. People like, you know, here people like algebra. For them, it's algebra is enough. Some people like analysis, no? That's why I'm bringing some kind of attention towards the analysis and topology. So here what I'm saying, like maybe the people who like topology and other thing, like there, we are also, simple groups are building blocks. So that means we have to understand the building blocks, right? In order to, so building blocks are good means the home is good. The bricks are good means the home is good, like that. So we have to understand the simple group. In fact, I will tell you one thing. The finite simple group completely classified into 4 categories. Okay, that is little advanced, and if you're really interested, you can go and learn from PhD point of view. But I can give you the links. Actually, I had included that link in the last talk. I sent to Vinod sir the notes, and those links are there. Okay. Anyway, so let us understand. We are here in a simple group. Okay. So many questions. I'm now little more careful. In the IIT Madras, when I was facing the second level exam, they asked me question from here. Prove that something is not simple. When I was in CMI, they asked this question. Prove that something is not simple. So in order to understand simple, it means it's necessary to go through via negative one. That means we have to understand the not simple. I am telling you why I took this, because in IIT, in the second level exam, they asked, in the, you know, in CMI, they asked me, in IISc, they asked me. In IISc, when I was there, they didn't ask me exactly, but they asked the previous guy who said he likes algebra. He shared his experience. So it's very important. And you can go through some of the experience shared by people in online. Directly, they are saying that the group 161 is not simple. Prove that. It is a TIFR question. They asked him in TIFR interview that I had included. So that's why I want you to focus on little bit on that, so that it will be helpful for many perspective. Okay. So what is simple? Exactly 2 normal subgroup. That is identity and G itself. Nothing in between. Okay. So the moment I say exactly 2, my group must be at least greater or equal to 2. If it is 1, I cannot use 2. That's why I am leaving the trivial plausibility. Leaving. This exact word comes from Professor K. N. Raghavan. When he was teaching us, he said the exact word. Most of the time, leaving the trivial possibility makes life very easier. So in order to make that, we have to make such definitions. Okay. And this kind of definition helps in a very, very much generality. Okay. So we know what is a simple group. The example is all prime groups, ZPs. In fact, Lagrange's theorem says that suppose I have a subgroup that will divide, the order of the subgroup will divide P, either it's going to be 1 or P. That means the subgroup itself going to be trivial or itself. That implies H is either trivial or H is itself. So we don't even have a subgroup. Then only we can ask about normality. We don't even have a subgroup. So this becomes a very prime example. And this is a one sort of this thing. Okay. I told you about 4 sort of thing. Sorry. four sort of thing. One is Z piece. Four sort of category. One is Z piece. The next one is actually ANs. And the next one is SLN FQ. Say PSLN type. This is much more advanced. It's in the high MSc level thing or PhD level thing. This is called sporadic groups, which are much more advanced. Okay. I don't know much about this, first of all, but I know about these three. These are the core things. But in a BSc level, one can understand this, of course. In the BSc level, anyone can understand. In the MSc level, of course, for AN and everyone should know this. In the level of first year PhD, everyone knows this. I know because of that, my coursework. This is a special interest. Whoever having a special interest, they can understand that. But understanding is not much harder. Understanding why these are the only simple groups that requires via negative idea. I don't know that, but still I can help in a way. Okay. So very interestingly, we can ask the question: first composite. The first composite occurrence in the 60 in NBH, sorry, in CSIR, I think 2019 or maybe 18. I don't know exactly. That's this question. If you have a simple group of order 60, then ABC, then ABC. It's going to be isomorphic to A5. It's maybe not going to be isomorphic to A5 like that thing. The virtue of deep application of Seilo's theorem will tell you every simple group of order 60, the first composite number, and we are looking for, it's isomorphic to A5. Okay. So the rest of the talk, how it's going to go, I will tell you. The rest of the talk, we are at the very good point now. We are going to understand why. Forget all the primes, okay? Forget all the primes. Just leave all the prime. Other than prime, up to 60, between 1 and up to 60, all the composite number I'm going to take. And I'm saying that why this is not simple. What is the reason? Already we have a very good thing. What is the reason? Already we have certain things, but let's go a little deeply. Okay. So already remember that. Note PQ, your P less than Q, both are prime. Not simple. We made it, no? Not simple. We already note that it is not simple. Because the corresponding to Q, the bigger prime, always going to be normal. So the Silo subgroup corresponding to Q, which is not trivial, not 1. Of course, Q is a prime, which is not whole because the group are a PQ. It's in between and it's normal. So you must have guessed what I'm going to do, right? Mostly I'm going to catch, okay, the Silo subgroups. Of course, because of Silo subgroup itself, not trivial because of it's related to primes. Hence, I'm going to catch them. So I'm not caring about triviality. If it is not full and it is unique, it's going to be simple. I mean, and it's going to be normal and simple. So the best way to do it, trying to get Silo subgroups unique. That's it. This is what I'm going to do. I'm going to proceed towards this. Okay. 12. Okay, the counting idea. Now I'm going into the counting idea. 12. Why did I took 12? Many examinations, this 12 plays a role. In CSIR, deliberately they asked this question. How many non-isomorphic groups are, classes are available up to isomorphism in the order 12? They asked. And Michael Artin, okay, in Michael Artin, let me put M. Artin, algebra book. Algebra. He dedicated a subsection on order 12. In fact, I heard this from one of the TIFR faculty. I don't want to tell the name, but he said that in the interview, they verify whether you've gone through the standard material, like standard notes. Suppose you say, let's say you like algebra and you are saying that I like algebra, and they test that too, whether you have gone through. Maybe such a question may be asked like, this is like You can answer only if you go through. He dedicated a subsection. How many non-abelian isomorphic class up to 12 happens? This is one of the TIFR interview question, and they asked in IMSc also, right? Always aim for the big. Even if you didn't get it, you will get very nice thing, at least something little lower than that. That's why I want you to aim for TIFR, IMSc kind of HRA kind of thing, CMA, right? If you like algebra, IMSc and TIFR, CMA is going to be very, very, very good choice. And there are other institutes, of course, but I know this kind of institute well. I'm saying that. Okay, fine. So I like you to go through the subsection on order 12, at least like, you may not be understandable without semi-direct product. It's a little hard to understand. I know. I can able to feel that thing, but at least try to understand what are the groups. Once you know what are the groups, how they are formed. So Michael Arden uses some kind of matrix to put it. And one of the TIFR question is very interesting. It asked about something like, every non-abelian group which has some property is always start from order 10, more than order 10. Something like that he has. Okay, let us see. If we have time, we will see that too. So far what we started understanding the silos theorem, the statements, then we did for PQ. Now I'm coming for the counting area. The direct area is not going to work, and I'm coming for the counting area. What is that? And when should I use the counting area? Two things are there. So what is as usual? Listen carefully. At the end of this talk, you will understand at least how to do this silos analysis. What I'm going to do, let's say n equal to 2 square into 3. This is 12. And n2 corresponding to number of 2 silos of group. And remember that those order is 4. So n2 divides the remaining 3. n2 divides the remaining 3. That means I will get 1 or 3. Also, n2 congruent to 1 mod 2. Now this says that this is also possible, this is also possible. This is also possible, this is also possible. Similarly, let us go for n3. n3 will divide the 4. Okay, the remaining is 4. Careful. So n3 can be 1 or 2 or 4. Also, n3 satisfies this equation. So it cannot be 2, but it can be 4. Now we are dealing with the 4 cases. What are the cases? The 4 cases. Case 1, n2 and n3. Okay, let me put case. Things are visible, right?
Yes, sir.
Yes, sir.
What are the cases? Both can be 1. There are 2 possibilities here. There are 2 possibilities here. Both can be 1. Or this can be 1, this can be 4. Or this can be 3, this can be 1. Or this can be 3, this can be 4. Look at, 1 second. Look at here. In the 3 cases, I'm getting unique in the first case. So one of them always going to be unique. So the order 12 is not simple, because one of them going to be unique. In the case 2, this is going to be unique. Yes, it's not simple, because it's order 4, which is not 12, which is not 1, and it's unique, normal. This one, the third case. Order 3, which is not 1, which is not whole, but still 1, it's normal. So unique, so not simple. But we have to take care of the one thing. n2 equal to 3 and n3 equal to 4. This one case is actually having a problem. Suppose this case is possible, we are not getting a silos, we are not getting a silos which is unique. That is a problem. So far I know if I get a unique silo, then I'm okay. Now I'm not getting it. We have to take care of this. Okay, let us take care of this. Okay, let me take care of this. Suppose I have this case. N2 is 3, N3. That is, take H1, H2, H3. So K1, K2, K3, and K4. These are relevant to 3 silo. These are relevant to 2 silo. But order is 4. Order is 3. Okay, remember 12. 12 is 2 square into 3. That's what I did it here. So I took this K1s. I took this K1s. In the K1 and the K2, K3 and K4. Count the first identity plus 2 more element, right? Because of order 3. This Ki is order 3. I already counted identity. I will get 2 more elements. Why this 2? You may ask me that question now. You may ask me. You already counted. Why not a overcount? This may be counted here, right? There may be overlap. That is not true because Ki intersection Kj equal to empty if I not equal to j. Why? Because of the prime. That's why we start the course just cyclic groups. Although we are doing Silos theorem, using as an excuse, I'm recalling most of the fundamental things, right? What is a cyclic group if a prime? Everything is a generator except the identity. So I should technically put identity. If it is more than identity, it will generate Ki, that will generate Kj, so it should be equal. So if the group is different, it cannot be more than identity. That's why I already counted identity, I will get 2. I will get 2 here, I will get 2 here. Totally 9. I just counted identity remaining elements of order 3. These are all of order 3. But remember that I have H1, H2, H3. Here also I have identity. Leave it. Already I counted. But remember, 3 more elements will come. Already 9. Now 3 more elements will come. Why these 3 more elements counted? You may ask the same question. Isn't it already counted? No, because H is relevant to 2 silos of group. Its order is 4. So every element is like a multiple of 2. Order is multiple of 2. Except identity 1, other thing is like 2 or 4. So that's why I did not count anything like relevant to 2. Related to 2, I counted this. And also remember, already I got 12. This 3 is coming from here. But this guy is different. We assume that this is possible. This guy is different from here and HI's order is same. Same like 4. There may be intersection. I don't care. There may be intersection. It's not like KIs. They are like intersect only in the identity. There may be intersection. But remember that even though it has an intersection, there will be some element which is not here. Otherwise, I'm not able to say it is, different, right? There will be some element. Some element will be get contributed. And that is a contradiction. Why that is a contradiction? We started from 12, something we are getting 13. Okay. That's a contradiction. So this is not possible. This case is not possible. Okay. Let me go through again. What is the counting idea? Okay. But with now the same idea I'm going to apply, but for 56. Okay. Just give me a moment. If you don't understand, it's okay. Now you can understand. There's a chance you can understand. Okay. Give me a moment. What is counting method? Now, please, if you help me, please. I start with 56. How should I split into primes so that you have to ascendingly? Tell me. Somebody tell me. Step 1 splitting. How to split?
2 cube into
2 cube into
7.
7. Second, silo analysis. Silo analysis means I have to go for N2, I have to go for N7. N2 will divide the 7. So answer is 1 or 7. Also, N2 congruent to 1 mod 2. That means N2 maybe 1 or 7, both possible. Because 7 minus 1, 6, that is divisible by 2. What about this? N7 will divide 8. 1 or 2 or 4 or 8. What are the things possible? 1 is always possible. 2 is possible. Remember that. N7 congruent to 1 mod 7.
No.
Let me put. Somebody say no. Yes. What about 4? 4
No,
minus
this is
1
not
is divisible by 7. No. What about 8? 7 minus 1 divisible, 8 minus 1 divisible by 7.
Yes, sir.
So that is. So we got again the situation. What is the situation? Case N2 and N7. What is the situation now? It can be 1, 1. Sorry. First case, 1, 1. Second case, it can be 1, 8. That's okay. Third case, it can be 7 here, it can be 1 there. Fourth case, it can be 7 here, it can be 8. Okay. Again, the same scenario occurs, right? Same scenario. After the silo analysis, the possibility of silo subgroups, counting area, it may be unique or not. We have two choices, but among these choices, look at here. We are getting unique. So the question is that whether the group is simple or not. The group of order 56 is simple or not. In fact, in the IIT, they asked us, prove that the group of order 56 is not simple. Prove that the group of order 56 is not simple. So we are getting 4 cases. Out of these 4 cases, somewhere we are getting unique silo. So not simple. Somewhere we are getting unique silo. Only the case we have to take care this 7. What is the case? N2, okay, sorry. N2 equal to 7.
This is not possible.
Yes, the same idea. We have to, not possible. I'm going to say this is not possible. Using the same counting idea. This N7, no? Okay, what is N? 2 cube into 7, right? The N7. Suppose true. Then I have a K1, K2 up to, okay, let me put K1, K2, K3, K4, K5, K6, K7, K8. Suppose it is possible, I will have 8 subgroups of N7. That means the 7 cell subgroup. Similarly, I can count down. So the Ki order is just, 7. So this will give me 1 plus 7, 1 plus 6. The identity will be there and remaining 6. This will give me 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 6. You can ask the same question for those people who didn't understand, I'm saying that last time, for them, I'm repeating with a new thing. You can ask the same question. Isn't it counted here? Suppose, let's say new element. What if not counted, already counted? What if it is already? That is not true. Ki intersection Kj, it's trivial. Okay, Ki intersection Kj is trivial because if I not equal to j, because prime, this is single prime, just single prime, not a power. That's a single prime. We know that it's a cyclic. This is a cyclic, except the identity, everything generates this. Suppose there is a non-trivial element that generates Ki, that generates Kj, so they are equal. If they are not equal, they are not intersect except identity. No intersection other than identity. That's why we are getting new element. So totally 1 plus 8 times 6, 49 elements I already counted. But remember that I have H1 and H2. In fact, H7 up to H2, H3, H4, H7. From here, take 2. I already have 1 And remember that this HI order is 8. And remaining 7 elements, these are relevant to the 2 silo. So 2 order. There I counted only 7 order. So this will like 49, this will arrange plus 7. But the same idea, this H2 is different from H1. There will be one element which is not here, which is not counted. So this will give me one more extra, which is like 57, greater than 56, contradiction. Although we started from 56, why should I go for 57? I mean, it is not possible. It is redundant. That's why this case is not possible. This case is not at all possible. So only these cases are possible. In each of this case, I am getting at least one silo subgroup which is normal. Okay. So good, very good. With respect to this understanding, one can go for PQR. I would suggest you to go for PQR. And you know something, before going PQR, go for this 3 into 5 into 7. We have to understand NP, NQ, NR and see the possibility. Before going PQR, general PQR, okay? We have a lot of PQRs, right? Before going PQR, go this. Understand that. You will get a lot of cases. Maybe 8 cases, maybe more than 8 cases, 2 possible, 2 possible, 2 possible, 2 possible. And remember that R greater than Q, greater than, I mean, P less than Q less than R. This condition need to be satisfied. Using this idea, 105 is very much easy. Use counting method, okay? So you will get a lot of possibility. First step, you have to split them correctly. Second step, do the silo analysis. You will get a lot of cases. Among the cases, look at the case where the silo is unique. All other non-unique cases you can neglect using this. You can just neglect using the counting idea. Okay, I want you to try. Even if you don't understand it, there are very prescribed things there in the internet. You can go through. Okay, you can ask me also later. Okay, so good, so far so good. But one thing I wanted to say the limitation of this. So let us even understand this question. N equal to 96. How to split? How to split? Any tell me? In terms of primes?
K into 2 to the power 5.
Sir, 2 power 5 into 3.
That is a correct way. 2 power 5. Whatever you said is also correct. But I always prefer, the increasing order. So we have to discuss N2. We have to discuss N3. Always one is possible. Always one is possible. Can somebody say, here 3 also possible? What about here? After doing all the silo analysis. There will be one more exactly. If you do the silo analysis, let us do. N3 will divide 2 power 5. That means N3 can be 1 or 2 or
1,
yeah.
4.
That is only possible. And N3 congruent to 1 mod 3. Right? N3 congruent to 1 mod 3. So this is not possible. This is possible. This is possible. 8 minus 1 not divisible by 3. 16 minus 1. Yeah. So N3 equal to 1 or 4 or 16. So remember that this 3, totally now we have 2 possibility here. Totally we have 3 possibilities. So that we have to consider case of 2 into 3, 6 cases. Among the 6 cases, 4 cases will be like unique. But this is getting very complicated, this is getting complicated. Even you just think about that N2 is like 3, N3 equal to 4. This case, consider this case. Okay, consider. Try and see. Counting not working. That means counting method not working. The counting method has some limitations. Counting method not working. If you're little clever, you can understand why. That's little hard. I'm not that clever. I took some years to understand why it's not working. I know it's not working, but why it's not working, I didn't understand. But if you're little clever, you can understand. Compare, I will give you the hint. That's what my senior did. Compare the nature of the prime in the previous example, 56, and here, in the nature of the prime. Once you understand the nature of the prime and the number of, there are two things. Once you have to understand the nature of the prime or size of the prime and the number of the subgroups, then you can get it why this is not working. From that understanding, you can able to use this method whenever it's possible. So this 96 is not working, right? We can use some very nice tricks. Those are called group action techniques, okay? But that's a little beyond the scope. So some BSc people are here. I don't want to scare them with the big words like group action and permutation representation. These are very simple once you are getting into MSc level, or maybe a little bit of second year MSc. It is very okay. So these are the thing. So far, counting method, direct method is okay. Direct method is direct. Counting method is very good. Everyone can understand. With respect to this understanding, let us go. Go for P square Q example. Okay. In the P square Q example, you can see that I'm directly doing, okay, NP and NQ. NP will divide Q, so 1R Q. So I'm not considering this. Because in the case of PQ itself having a lot of problem, no? I'm very interested on that. NQ will divide P square. So there are three possibilities. 1 or P or P square. Remember that P less than Q. This is not possible. P minus 1. Q does not divide P minus 1. But there are possible. Q may divide P square minus 1. Example 12. 3 divide, 2 square minus 1. 2 square is 4 minus 1, 3. 3 divides 3. Okay. Another example, one can go for 12, I think. I'm not sure, but yeah, not 12. There are some other example, of course. So this is example where it's not dividing the P, but this divides this. So again, we have a possibility here. What are the possibility? 1 or Q. I am very much interested on this NQ. I'm getting two possibilities, 1 or P square. It's either 1 Q silo subgroup or P square Q silo subgroup. Okay, let's understand that. Suppose NQ equal to P square. I'm not considering about a NP, okay, that's little hard, but this is easy. That means P divide P square minus 1. That's okay. That means P divide P minus 1, P plus 1. That implies Q divide P plus 1. Because it's already less, P less than Q. Already less. The prime dividing AB, either prime divide A, prime divide B. So this. So P less than Q less than or equal to P plus 1. You can see there is a one change. Only one I can jump. P is a prime, Q is a prime, but Q must be next to it. So P, Q equal to P plus 1. So they are next to each other. What are the only possibility? This implies P must be 2, Q must be 3. Once you account for 2, there is no prime next to each other. All the even number cannot be prime other than 2. It's not prime. It can't be prime. But now we are getting a case next to each other. If they're next to each other, that means it must be 2 and it must be 3. That implies N equal to P square Q is 2 square 3, which is 12, which we discussed. And this is one more reason why we are discussing 12 alone. So this case not possible. If n not equal to 12. The case is not even possible when n not equal to 12. If n is not equal to 12, this case is not possible. That means always simple. Any order p square q is always simple. Other than 12, then we have to discuss the 12 alone. Then you can see that 12 is also not simple. Okay, understood? I hope you are always following, right? Yeah. So at the end of the day, at the end of the talk, at least you should know how to do this silo analysis. Okay. So little by little, I'm adding the components. Okay. Okay. So far, what we have, we got this NP square idea. So this is what I explained here. First, let us summary. Whatever we did, let us summary. PQ, not simple. Okay. PQ, not simple. 12 is not simple. P squared Q type, not simple. PQR, I asked you to do, and we are assuming that's not simple. And there is a very famous theorem in the P groups. The center of P group is not trivial. This is so famous. If you don't know, just know by now, the center of P group is always not trivial. I already told you what is P group. The order is as nothing but power of primes. Prime and power. Not a composite of 2 prime. There is no 2 prime, only 1 prime involved. The center of P group is always non-trivial. So that means other than ZP, okay? So the center of P is not trivial. There is one more I should add. If P divides order of G, there exists an element of order P. And one more thing I should add, any subgroup of Z, normal. Any subgroup, including ZG, any subgroup of ZG, including ZG, is normal. And this is why non-prime, ZP, non-prime, any abelian group, or maybe any P group, not prime, not simple. If it is prime, it is simple, otherwise not simple. Because we will get a center. In the center, there will be element of order P. Okay, what I'm trying to say, if you start with a group, which is P power, let's say beta, greater than or equal to 2, then it has a center, non-trivial center. And it has a group, subgroup of order P. This is normal here. This is normal here. Any subgroup of center of G is normal here. That's why this is normal. Okay. Now, what we are going to do? Maybe, okay, let us say that some of you may not follow it up to now. But look at this list of things. PQ is not simple. 12 is not simple. P square Q is not simple. PQ are all not simple. And P power square from square cube up to P. P is the only different. P square, P cube, nothing is simple. Use these 5 results to tackle this, okay? Okay. So this is what I made. The reason also there, 4 is not simple because 4 is P square. 6 is not simple because 6 is PQ. 8 is not simple because of this thing. For example, there are stars I put. That means they need to be discussed. Or you can make it. For example, 18. Look at 18. Look at 18. How to split the 18? Somebody saying something? 2 into 3 square. You can alone discuss this, or in general, you can discuss P into Q power N or Q power K. You can discuss this. You can also discuss at P power K Q. What happens to P power K Q power K? Also, you can discuss P power alpha Q power alpha. You try discuss this generally. Do the sign analysis and see that. You can alone discuss, or you can discuss. For example, this is 2 square into 3 square. What happens to P square Q square? Is there any way? anytime we can do. So since I had included this, and I also want you to try these things alone or doing this up to you, but at least one can do from now. 51 to 60. Try to say. So just go through this. I had written wait, not this one, this is 9 actually. I had written the number and gave the reasoning why that is not simple. We will try the same thing for 51 to 60 now, just for the practice, 51 is a prime, I guess. Let's try for 52. 51 is a prime. Is it prime? No, right? No, not a prime. 52, but 53 is a prime again. 54, 55, 56, 57, 58, 60. 59 is a prime. 57. Okay, how to split them? Is it a PQ type or P power type or PQR type or P square type? Anything? How to split 51?
3 into 7.
3 into 7.
So 7.
3 into 17.
So PQ type. Not simple. What about this?
2 square into 13.
4 into 13.
2
square into 13.
P square Q type. What about this?
3 cube into 2.
2 times 3 cube. Yes, sir.
So discuss alone. Let me put star. 55 is, 5 into 11. 56.
2 cube into 7.
I didn't discuss this. Discuss alone. In fact, it is true. P power Q also this works. Corresponding to is always, maybe discuss alone. Sorry, I made a mistake. Discuss. What about 57? I think 19 into 3, 3 into 19,
Yes, sir. Yes.
58, 60, I'm not care about.
2 into 29.
PQ type. So there are 2 more you need to discuss. And ultimately 60 is the matter. And 60 simple implies AFL. Isomorphic to AFL. Isomorphic, okay? So that's why, but at least you have a very good idea, right? After all this working out, just finally we got a very nice tool. PQ type is not simple, that is not simple, this is not simple. So you can now work out and include the more thing. I found a very nice PDF. Maybe I will ask one of my students to send it in our group. I don't think I have it because I changed the computer, but I asked my students to give it to me and I will forward to you. So one guy prepared a very nice thing. He discussed about 24 alone. We discussed about 36, 48 alone. 48 also need to be do alone for certain reason. So you can see that many second level exams in IIT has these things because they did not fit into this PQ type, Q type, that type, and this type. Especially for example, 48 is not fitting into many type. So people ask the question, 45. 45 also it's like, P into like we have like 5 into 3, 3 square into 5. So P squared, I think it's a P square type, right? 3 square into 5, yes, P square type. Yeah, this is P square type. But the 48 and that guy prepared a very nice PDF. That also I will send by end of this day. So yeah, so we got it. So yes, so this is what I want to say. Now let's go through the few questions about TFR. Okay. The first question is a true or okay. Before this going TFR actual question, let's go to these are the questions they asked in TFR in the interviews. Okay. Remember that this is a question they asked in. Try this. For example, let us try 161. How can I split? Definitely 2 will be there. Then what are the other things? Can anyone say?
308.
That's okay. I want actually in terms of prime. I know just like dividing no 616 by 2 is 308. That's okay. Product of primes.
2 to the power 3 into 7 into 11.
2 to the power 3, 8 into 7. Yeah, that's okay. 11 is a factor. Yeah, 616. 6, 6, 12, 12 plus 1. Okay. Yeah, yes, correct. So now, then it's like it's again you have to go through N11. N11 is a kind of a little good choice because it's like little higher and a little good choice. So N11 will divide 2 cube into 7. It can be 1 or it can be 2 or it can be, yeah, you have to do is that's what slowly do this using counting. I hope that counting method works. As far as I know, counting method works. You just try for N7 and other things, and you see that N7 should be like, the thing, the correct thing. Or otherwise, you have to use like PQ or same technique. Okay. I'm just saying these are the things they are in the exam they asked in the interviews. Okay. So let's go to actual question they asked. I just included 4 questions. So may I take some few more time, sir? Usually we have to stop at 8:40 then question time. Hello? I think Vinod sir is not here. Hello?
Yes, Jay, yes.
Okay. Okay. So yeah, so this is the actual question they asked in TIFR exam. Let G be the finite group, P be the p-Shiloh subgroup, where P is prime number. Then for everything is a p-Shiloh subgroup. Okay, that is true. Why it is true? P-Shiloh subgroup is there in G. Okay, let me go to. We have a p-Shiloh subgroup in G, then another H. Now P intersection H, whether it is p-Shiloh subgroup or not, that is a question. And we say, yeah, it is. How? So you know that to show something p-Shiloh subgroup, it should be the maximal. Of course, this is contained in P. So it is a P group, a P subgroup. That is no doubt about that, because this itself P, so it's a P subgroup. That's not a thing, but it's a maximal thing. What it should be like a maximal, okay? But we have to be a little more careful. These TFR questions are so so temptable, and we can say, yeah, it should be no. It's like, yeah, it should be like a P subgroup or something. But in the lecture, I have mentioned again and again. Let me put it. At the first glimpse, this may seems true. TFR and NBHM questions are required to control your temper. If you don't have a control over your temperament, it is so hard. In the lecture itself, I had requested to go through this. Okay, let us understand the question again. This question just asking true or false. If G is a finite subgroup, it's a p-Shiloh subgroup of G, where P is a prime number, then every subgroup H, G intersection P is a p-Shiloh subgroup of H. They're asking this question. But remember that during the lecture, I was explaining about the two things. Suppose this is a p-Shiloh subgroup, and there is another p-Shiloh subgroup. They may intersect. So take this as a P, the given P. Okay, this is a P, the given P. Now you can take this as a H. This is also p-Shiloh. Now this intersect. This guy. This is H intersects P. This is contained in H. But H is maximal actually. Itself. Right? So you have to be little clever about this. So tempting to do that. Yeah, so P is a maximal. So intersection with every subgroup is maximal, right? But that's not true. This P is maximal with respect to this. This P is maximal with respect to that. Take that is. when the intersection happen, this intersecting guy is certainly a P group, but with respect to H itself a P silo. So H is maximal itself with respect to itself. Initially, I thought it is true, but later I understood this is not. This is actually false. This is not true. This is not true. The explanation is this. That's why in the lecture I took some time to explain this thing. The intersection of two P silo subgroup, right? They may have an intersection. So there are examples. They may have intersection. There are examples. Okay. Okay. Let's go. Oh, forget about this question. Just forget about this question. Let's come to the next questions, and we will do some questions, and we'll come back if we time. This requires some kind of explanation.
Excuse me, sir.
Okay. Yeah, please. Yes.
Sir, in the previous question, H is not given to be a P silo subgroup, no?
Yeah, but they are saying no. They are making a statement for every group. So they are making a statement. If this is true, then it's for every group, no? So in particular, it is true if I choose H to be P silo. Correct?
Okay, sir.
Yeah. So yeah, these are the things. In good universities, they teach one course in mathematical thinking, especially logics. So sometimes things can be understand through those courses. Like, so if you have some internet access, go to this Harvard Institute. They have a very good course on mathematical thinking. They deal with this thing. For example, to negate this statement, I have a feeling this may true, this may not be true, right? I have a feeling this may not be true. To negate the statement, whenever there is a every, then I have to show there exists. This kind of stuffs are very confusing. Necessary and sufficient, and this kind of something are little more, like she asked. It is for me also. It is confusing. So we have to be very careful. Wherever the every word, what is a negation to that? What is a complementation to that word? Okay. So you must have heard about Professor Keith Carnett, one of the great professor and who writes very nice notes. Recently, in his blog, expository article page, he included a very nice PDF called writing the tips to write mathematical papers. There he had explained about this symbol. This is for all, not mean all, not meaning all. Okay. For example, all matrix with determinant non-zero is invertible. Suppose all matrix with real entry with a determinant not zero is invertible. That makes sense. If I put all matrix with real entries, determinant not equal to 0. But if you put like this, for all matrix non-zero, it doesn't make sense, no? He talked about all this matter in the one single PDF, consists of 10 pages. I strongly recommend you to go through that, okay? Okay, so Professor Keith Carnett, expository article, tips to write math papers. Okay. So the third question, a p-silo subgroup of underlying additive group of a finite commutative ring is an ideal of R. Okay. So during the lecture, I keep stress the word maximal, right? Maximal, something like that. Okay. Also, I keep stressing something like a unique if and only if normal if and only if unique. Something is going to play a role. So let us understand this. So let's understand this. All the thing which I had given in the lecture are so important. Remember, every word is important. That's why when Vinods are uploaded, please go and see once, at least once. So I was telling about something normal, unique. Unique means normal, but we are now using a normality to show something uniquity. Okay. What is the question? See the question. Let us take R, commutative ring, finite. Take P as a subgroup, P silo, under addition. So what they are saying, a p silo subgroup under is whether it's ideal or not. First of all, this is subgroup, no problem. Okay. First of all, this is a subgroup. To prove ideal in a ring, what I need to do? I need to do this thing, right? What I need to do? I need to do whenever there is a let's say R belong. Okay, let me put A belongs to ring, and some X belongs to P. Then AX belongs to P. Since it's a commutative, one side is enough. Telling one side is enough. But remember that. Try to understand this. R to R, X going to AX, A not equal to 0. This is because of that property. What is that? The property of the ring, no, the assumption. Distributive law. Because of distributive law. This is additive homomorphism. You have to realize this first. Because of distributive law, this maps, let us call this map like phi A. A is fixed and non-zero. Even 0 it works, of course. Phi A takes X, phi A of X equal to AX. That means this guy additive homomorphism. This additive homomorphism guy takes my P to something PV. But remember that the order is same. Okay. But may not be same. If it is here also, you have to be control the temper. I may use a rough word like same. That is not true. Because if it is not integral domain, it may not be same. This is may not be like, it has. But one thing is clear. One thing is clear. The one thing is clear. This is a P subgroup. Why? Why it is a P subgroup? Okay, we have to understand that. Why it is a P subgroup? Okay. See, suppose X is of order P. That means X plus X and P power alpha. X P power alpha, it is 0. I'm in the ring setup, that's why I'm using 0. Otherwise, I would use 1 or E. Suppose this is the way. This is the thing. And what is PA of X? Which is AX, right? Then remember that PA of X, A of X, that is AX plus AX plus AX, P power alpha time, right? P power alpha time. Now I can take A out, X plus X plus X, P power alpha time, which is A0 equal to 0. That means PA of X getting, I mean, it's not, may not be order P power alpha, but this order certainly divides P power alpha. We know that, right? We know that from group theory. That's why this capital P is a P group. But remember the second Solo's theorem. Second Solo's theorem I included because of this question. Otherwise, I just could have said the corollary. Every P group is a sub of P Solo subgroup. Okay, that means this is sub of P. And you may ask now, why are you putting P? There may be another P Solo subgroup, right? There may be another P Solo subgroup, let's say P dash. It may. Why that another P Solo subgroup is equal to P? This is the TIFR questions are getting so beautiful, so qualitative. Remember that under the addition, this is epidemic. So that implies unique P silo. Every subgroup of a abelian group is normal. So normal implies unique. So there basically only one P silo. There is basically only one P silo. Okay, there is only one P silo, and every P group contained in P silo. That's why I tried this. This is actually P group, P subgroup. So every P subgroup contained in P silo, but that is nothing but P because of this unique. So that means P power A, not alpha, AP contained in P for every A belongs to ring. That is AP contained in P for every A belongs to ring. That implies it is ideal. Right? Yes, somebody wanted to ask question. Okay. I just wanted to know that you have to control over the temperament, and the questions are even just, inky pinky ponky like that. True or false? Yeah, it's true or false. It's true or false. One can put, but we have to be very careful. In this question also, it is very much tempting. You see, we all discussed about P square and Q. So, and we made a thing. Anything corresponding to Q, it's like a kind of, something. But all of a sudden, look at this. There is something is defined. Okay, something is defined. Okay, remember that. In our lecture, P square Q, while dividing P square Q, except 12, the Q subgroup is normal. Except 12, the Q subgroup is normal. But here they make something. You have to be very careful here. This means P does not divide Q minus 1. P does not divide Q minus 1, okay? So we have to control the temperament. There is an extra condition. Okay, let us understand this question. So let me copy this. Oh, sorry. I think it didn't get copy. This shouldn't get copy. Give me a moment. I will copy this. Let G be a group. Suppose G is P square Q, where P and Q are distinct primes. They did not say about the thing also. P and Q are distinct primes. They did not say P is less than Q, P is greater than Q also. Okay. So this is the thing. So then the number satisfying Q does not come to 1 mod P. Which of the following is true? Can anybody answer with respect to this theorem? Anyone?
Option 2.
What is option 2? G as normal P silo subgroup, you are saying. Okay. So we have to do basically silo analysis, right? NP and here NQ. NP divides P. So it's like, NP divides Q. It's 1 or Q, right? It's 1 or Q. So that means 1 is always possible. What about Q? Suppose Q is possible. P divides Q minus 1. That's the only thing, because NP congruent to 1 mod P. But here they are saying that it is not. Correct? This means Q minus 1 not divisible by P. So that's why the second answer too. But what happens? People see this, they will get tempted. They will just get tempted. One out of this temptation, they just go for this. Okay, it must be true. Because I have seen this in the lecture. I have seen this in somewhere. Correct? That's why you have to be controlling your temptation. Even do some 3-4 questions correct. That's okay. But it's a very good practice of you. I will share these notes maybe later. The good practice of you. Of course, the second one is correct. Why the first, third, and fourth not correct? If you think about it, it will be helpful for true or false questions. Okay. And remember that whenever you give exam, suppose you are getting selected for interview, they having your exam paper. They will directly ask why you put this answer. Why didn't you go for this answer? This happens with me in CMI interview. They asked me, they had my question paper. They just ask me why this is not true. Why did you write this like that? Okay. So good institute, they take very few people and requires, some kind of this thing. Okay. So 45, you will see that at least in the silo analysis, both silo are unique. You will see that both silo are unique after analyzing. Try this, okay, 45. Yeah. So these are the few questions, infinites that I added. I think I don't have a time. Maybe in the next or maybe some other day I will explain. To balancing out, we had so much about finite groups. To balancing out, I added this. This I may maybe talk about later. Okay, now it's like a question time. So yes, it's a question time. So you can ask questions.
Okay. Yeah.
Well, in the previous question, like it was given that Q is not congruent to 1 mod P. That
Right.
means P does not divide Q minus 1, right? So can we say
Yes.
that group will be cyclic?
No, that's a little hard actually. So, and you are saying that, okay, give me a moment. Give me a moment. Can you tell me again? Sorry.
Q is not congruent to 1 mod P means P will not divide Q minus 1.
Yes.
So does that mean G will be cyclic? Because we have
So,
seen earlier that
group order is like, P square and Q. So this means we can able to say okay, I understand your question. So there is relevant to P is R1, relevant to K. If it is not 12, okay, it is not 12 because of this. Yes, you can say. You have to be using direct product. You have to use the direct product. Yeah, you can say.
so if it is cyclic means then every subgroup of a cyclic group will be normal.
Correct. Yes.
So using that we can say can we choose the options?
So okay, I understood the question. So the question, since it is cyclic and you wanted to conclude that every cycle, that's what you are saying, right? Okay. I never thought of this thing. So the MCQ question type, the first thing is G has more than one P silo subgroup. That is not true. The second one, G has a normal P silo subgroup. That is true. And the third and fourth is talks about the number of Q silo subgroup of G divisible by P. That is not true. And G has a unique Q silo subgroup. They are talking. Maybe the fourth one is more relevant. Okay, we have to go through this little bit. I understand your point. Maybe I will go through and let you know.
Okay, sir.
It's a good point. Really good point.
Sir, I didn't get that first problem actually. H intersection P, why it can't be the P silo subgroup?
Yeah. So the question is, okay, I will read the question. Suppose you have a P silo subgroup, let's say P, and they are saying that they make the statement, you take any subgroup H, now intersect with P, then the H intersection P is a P silo subgroup of H, the subgroup. So this is what they are making the statement, right? I'm saying that is not true because you take two different P silo subgroups. Suppose they may have an intersection. They may have for example, two P silo subgroup which are only intersection are trivial. So different. We got some cases like in the 56. So different, they intersect only at the level of trivial. Now take H as a one P silo subgroup, P as a one P silo subgroup. Now H intersection P is a trivial. That is a certainly P group. That's order P power 0. But that is not a P silo subgroup, right? 2 was the H. Because H order, for example, 56. Take 7 relevant to 7. The P is the first silo subgroup of relevant to 7. Q is H is a silo group of relevant to 7, second silo group. The P intersection to H as trivial because both are different. But with respect to H is the P silo subgroup, correct? So this trivial is not a P silo subgroup of H, correct?
Yes, sir, got it. So counter examples we used is another P silo subgroup will be the counter example, right?
Correct.
Okay, sir. Yes.
That's why I am putting more structure on that picture. When you have the picture now in the mental image, it will come up in the exam.
Good evening, sir. I am Dharmendra Singh from BARC Visakhapatnam in library. The lecture was very useful and beneficial for TFR, CMI, IMSc, and other exam also. Some questions are very good and high level question compared to IIT JAM, etc. How to self-prepare for CMI, TIFR, ISI,
CMI, right?
IMSc type integrated PhD entrance, PhD also, PhD interview also, and tell some reference book except Martin Galen algebra and for other subject also. Share your PhD experience at IMSc Chennai. How is
Yeah, I'm
far
still doing.
from CMI?
IMSc is like nearly 22 kilometers far away from CMI. There are subtle connecting from IMSc to CMI, and it's mostly like co-institutes. There, people say it's like co-brother institutes. This kind of things I will say later, maybe after the time. It's a good thing. Maybe I will share in the group, Vinod sir, about my thing, and we make another like friendly section where we can talk about PhD interviews and other thing. Now maybe we can address the questions about the lecture and other type. But you may message me. I will tell you about this thing. Okay, Dharmendra, is it okay?
Yeah, we can discuss that in a later occasion on another session. Yeah.
Yes.
Okay. Yeah, Dia.
Sir, am I audible?
Yes, Dia.
Hello, sir. I am Dia from MSc third semester, and I am also preparing for TIFR exam. So this lecture was very helpful to us, like how to get a picture, how to prepare for the questions like true and false and other MCQ questions. Like you have said, to collect more examples. Sir, I have one question. When doing the silo discussion at first we are we are doing the we are writing n as p to the power alpha into q some like this form, and then
Right.
we are finding the np and nq. Then this that subgroup we are doing that subgroup that like you have said for 12 that there are three H1, H2, H3 and K1, K2, K3, K4, and
Correct.
then we are counting the elements of K1, K2, K3, K4,
Correct.
and
Correct.
H1, H, and
Yes. First
we
we
are
are counting
checking
the
that
case.
it's equal.
Mm.
We are checking that it is equal to or order of G.
What is the counting method? Okay, this counting method is actually a negative. Why a negative? That means this counting method used to say something is not working. Okay, so this counting method helps us to show that suppose certain cases possible, suppose then we are getting more elements than what we started with. For example, 56 we started with, but we may get more than 56. Maybe we started with a 12. We are getting more than that. Okay, this counting method used to negate saying that certain cases are not possible. But there is another method where the counting method, for example, in the 96, counting method will not work. Though those cases are possible. And I'm telling you, I want you to go through, but I'm telling you, there are 4 methods. One is a direct method, another one is counting method that you know. The third method is called a group action method. The fourth method is called intersection of certain groups. Okay, this is very high level, and people don't ask in the level of our, in the IMSc CMA exam also they don't ask. This is like very PhD level. But there's 3 method can be asked. If you see the nature of 96, 2 and 3 involved, very small primes. 2 and 3 are very small prime. Whenever there are very small prime, this counting method will not work mostly. Whenever there is a large prime, the counting method will, in a certain way, when the large primes and the large number of, the large prime means large number of p-cellular subgroups are coming, right? Q-cellular subgroup. That is the key to count. So large numbers are coming. That means this is not going to be possible. But in the case of 96, even though the group is so bigger, 2 and 3 are involved, you don't get a large number of, because of 2 and 3. So the certain cases are possible. So this counting method so often to use to negate, right? So this is a guess. So whenever there is an exam, especially in the IIT second level exam, they may ask this question. I know IIT Madras asked this question. Now also last term also they asked this kind of questions, right? So am I answered your question?
Yes, sir. Thank
Yes.
you, sir.
Yes, thank you. Thank you.
Thank you, Dia. Thank you.
Somebody talk there.
Yeah, it's Harita. Yes.
Am I audible?
Yes.
Yes.
Hi, sir. I'm Harita. I'm a final year BSc student from Kerala. Your session was very a bit higher level for me, but still I was trying to understand and I have understood something somewhere. I will have to rewatch the video. Thank you so much for your efforts for us. And it was a very different way of thinking, and you are motivating us to think more. Thank you so much. Thank you, Vinod.
Yeah, I got this thinking majorly from 𝕨𝕚𝕥. Okay, so if you are planning to study for MSc, you will come through 𝕨𝕚𝕥. 𝕨𝕚𝕥 has a different counting method than Riemann. Certainly, he capture everything of Riemann. So this 𝕨𝕚𝕥 way of teachings are there in there. So I always go in the way. So usually people go what they want, they will prepare, but I always go in this way so that the conceptual is there. And in the notes, I have written that you may not understand. That's okay. Yes, of course. If you are in the final year BSc or something, certain things you are. But if you can understand 20, Ken Dragon always say 20 to 25%. If you understand, you can develop because you got 1/4. Later on, when you are in MSc, you will get the same thing. You will encounter the same thing. You will relate. Okay? You will relate, and it will be very nice, and you can relate. Obviously, it's about relating, right? Mind means relating, so obviously it's relate. So if I give you what you know, and if I exaggerate, I can only fantasize about that, right? So Keith Kannur mentions that mathematics is subject, not subject to time. Time, it means fantasization. If I give you something that you know, it's not going to be worth it because I can impress you only by fantasization. But if I start something you know, then go through, and you are at the path, and you can go to the path because you are at the point. So that is a motivation. So you can motivate yourself and go. This is my primary idea. And I think the BSc student, if they understood 30%, it will be great. And remember that this is not subject to time. It's all subject to the effect that you do, right? So you can capture. Maybe I am like in the final year of my PhD in the very long way. Maybe 7-8 years ahead of you. So I can give these things. But remember that when you are there at my age, you will be more than me, right? Because of technology and other things, you will be more than me. So you are just happy that you got to know something that you don't know. Thank you.
Yes. Okay, thank you, Harita. Others?
Hello,
Yes.
sir. My name's
Yes.
Alina Anna Matthews. I'm also a BSc final year student from Kerala. Thank you, sir. This was an entirely new topic, but you have made it simpler for us. I understood little bit, but most probably I'd understand more if I watch the class again. Thank you, sir. You motivated us to learn new things. Thank you, Vinod, sir, for such a wonderful session.
Thank you, Alina.
Excuse me, sir. I want to ask some question.
Yes. Dharmendra, yes.
I want to ask some question. For silo group, what prerequisite group theory in group theory?
Basic prerequisites, no, it's about, see, you have to understand very deeply the Lagrange's theorem. Once if you have a very good understanding of Lagrange's theorem, few examples, and you can see that Lagrange's theorem is very good up to the abelian groups. But if you go for the non-abelian groups, it's not good. Abelian groups are very nice, okay. There are 3 lectures of Jayakumar, my guide in YouTube, is from IMSc professor. You can see that using the 3 linear algebra idea, he classified all the finite abelian groups. So it's not so interesting. Once you understand that thing, the moment you feel that it is not interesting, you will start understanding the non-abelian group. And the first place to understand non-abelian groups are P groups, because you have a lot of similarity, lot of commonness, because that the center is not trivial, and you can see that certain things are gained and certain things are lost. Once if you able to understand that first, then you will get the idea what to do, and you will be like silo, not like understanding silo. You will be have a exactly frequency where silo had. Okay, so one of my friend always says that whenever he works for that theorems, he said that I am getting a vibe of the time. It's a transcending to. I'm again saying the proof done by silo can be understood, but can be relived. But the same test of silo you need to have like that. So silo has the basic questions, right? Why it's happening, why it's not, why Lagrange's theorem. So you must have ponder over certain things. Okay, so that's how it is coming, and that's my idea. Creating some thirst in you. Out of this thirst, you may have a very good interest. Out of the interest, you will do well. Out of the doing well, you will do get something. And out of the overflow, you will come for sharing, not giving back. That's what happened to me. Now, I like to thank one of my senior. His name is Krishanu Da. We call Krishanu Dan. His name we call Krishanu Da, a Bengali. He did the same thing. His classes are so difficult. The next class people used to come like a 40. For his class, 4 or 5 people attend. It is very hard, but still he made the same thing. He motivated us so that I turned and I am giving. So many people are there, right? So that's the basic idea. Instead of giving the solution, I don't like to give solutions. It makes you, the lame. In Tamil we call lazy person, somberi. That happened to me. Some people were giving solutions. But if I give you the test, certainly some spark can happen. That's what I'm saying. It's a very good question. You have to have a very good test of the silo. So you must have pondered over lot of non-abelian group. Once you are started understanding lot of non-abelian group, then you will get it. There are 2 ways to go. One by yourself, going towards the material. Another by the discussion with great people. Like for example, K. N. Raghavan or Vijay sir. And there are some people are there in algebra. Vishwanath. I know these people because I'm in IMSc, but there are very good people in other places. So yes, I'm answering your question.
Sir, can you prepare some chapters of? Yes, sir. Yes, sir. Thank you, sir. Can you prepare in notes your chapter from Galen and M. Martin? I have both of these books.
I need to prepare notes on these books you are saying. That's what I'm getting.
Notes, which chapter? Or chapter number?
Okay, maybe we can talk in the WhatsApp. No, you can explain much better there. Because of time lacking, I may not understand what you are saying. We can talk about that. I have a WhatsApp number. I will chat. No problem. What about other somebody trying to talk?
Yeah, it's Shikha.
Good evening, sir. I'm Shikha, second year MSc student from Birla Institute of Technology, Mesra, Jharkhand. So your session was really nice. Your explanation was very easy, and the way you were explaining each and every theorem with its application was really wonderful. Sir, I just wanted to ask that what all topics we should focus on for this exam, for this TIFR exam? Yes,
so that's a tricky question. Yes, so I found there is one notes recently came up. Dr. A.P. Singh. It is a kind of a good book. He compiled all these necessary things. I found that is like nicer relative to the others. You can go through the standard text, but I would suggest that pick up like that notes, like Dr. A.P. Singh. There are many notes. I just gone through the A.P. Singh only. There are many notes. And I also want you to go through the Professor Keith Kannur. Okay, I will share the link. He has lot of notes and he mentions everything. I heard from somebody. Some of the questions are coming from that notes. Similarly, for analysis, there is someone called Gilbum. Just put problems in analysis by Gilbum. Definitely 1 or 2 questions from NBH will be there. 1 or 2 questions in NBHM will come from that book. Okay, so that is for analysis. For algebra, Keith Kannur notes are best. But for overall, because we have shorter time, you may rely on these notes like Dr. A.P. Singh or some other institute notes. That's what I say. But if you have a good time and you wanted to really prepare for other people, I'm telling, these two things are algebra and analysis are so good. For NBHM, you don't have a choice. You have to go through this Monkus topology. There is no way to escape. The Monkus is the only thing that is like the ultimate topology. I think I answered your question, right?
Yes, sir. So what will be your last minute tips for us?
Oh, last minute. Okay. So, how many hours this exam, first of all? This is the written or a computer?
So computer based, 3 hours.
Computer based, yeah. So this is going to be weird, but this works for me. There is someone called Vedatri Maharishi we have. He taught us eye exercises. I use that eye exercises, which helps me. And without using those eye exercises, I stayed for 6 months and see there are some difficulty in the reading and even in the computer. No, for me, I am from IMSc, so I have to spend a lot of time in doing computer. So I had a lot of problems. So I was saying for 6 months and it was a lot of problem for me. But now, so for example, this is not a power class. This is 0 class, okay? Those eye exercises are so good to me. So I'm keeping myself to words. And so certainly 1.5 hours I can see without any hesitation. I can read using the iPad and laptop and other things. Okay, take good amount of glucose. Glucose are digestible very easily than fructose. This both will help. This is I got from a NEET preparing student. One NEET preparing student told me about this thing. So they also need to also see a lot of computer based materials. For them, it's very hard to go through all these things. So they said that if it's glucose and other things, in the exam they use glucose bottle, I mean water with a bottle and these things. And this eye exercise will help. These are the physical level. But for last time preparation, for preparation side, I would say that I go through such a notes in order to understand. Today, like initially I start warm up, no? Some BSc people may not even know that index to subgroup is normal, right? But you must. You are from MSc, then I think you are from MSc, I think you must know that. So this kind of, at least they know as information level, they may not confirm. So better to go through this thing, okay? Don't study anything before 1 or 2 hours. Just go 1 hour earlier to the thing, don't study. Otherwise you keep tensing, those won't come back. One day, maybe I will request Vinod sir to keep that thing. There are certain music can help us because whenever you study and you just put a music on before the studying, you will get an idea. So the next time when you put the music on, you will get the always that idea, studying idea. Just before going to the exam, when you listen to such a music, you will get the preparation vibe. This is a very good take that American student, I mean, Chinese-based American students are using. I got it from one of my friend who is a Chinese. He's in America, and he said that these ideas they are using. It's called the Taoic ideas. Okay, maybe I will share these things one day when Vinod sir gives some. Just after this exam, we can talk. No feedback section.
After all these tips will work. There may be lots of individual differences will be there. Some tricks that will be suitable for someone may not be that much effective for.
True. One night
so you have to find out your own techniques to energize you, to keep you concentrated on your
right.
Yeah.
Once you go through the structuring, you can understand that whether it's working or not. That's what knows out of this not working, you will find something new. Then you will come and share.
Yeah.
Yes, sir.
Yeah, you can experiment with that.
Right.
Yes.
Thank you, sir. Thank you, Vinod, sir.
Thank you, Shikha. Yes. Any
So
others?
what was the book which you said for algebra just now?
I suggested some book for algebra, right? Professor Keith Kannur notes. I will share the link.
Jay, we can include in your notes. You can.
Yes, I will include in my notes. Yes.
Yeah, that will be better.
I will include that.
Okay, thank you, Rosina. Yeah, Arya, yes.
So my name is Arya. I'm from third year BSc Maths student from Kerala. First of all, thank you, sir, for this nice section. And you explain new concepts and ideas for us. And I think I can understand more about the topic when I watch the class again. And thank you, Vinod, sir, also for conducting such a nice section for us. Thank you, sir.
Arya.
Hello.
Yes, Nishita.
Yes, I'm Nishita Pandadkar from BSc student from Maharashtra. Today's session was very excellent. I'm very thankful to you, and also I'm very thankful to Vinod Kumar sir also for connecting you with us. And thank you.
Thank you, Nishita. Yes, Rosina.
I am Rasina from 𝕨𝕤𝕦𝕤 VTB College. I can understood more about abstract algebra and more about the good information for studying JAM examinations and also. So thank you, sir, for conducting such a wonderful session. Thank you, Vinod, sir.
Myself, Zahra Rumesa. I'm from TMG College, Tirur, Malappuram. First of all, this section is very nice, simple presentation and easy to understand. And thank you Vinod sir for conducting this section.
My name is Aparna Lal. I'm a graduate student. The topic which you taught us today, for me, it was a bit high. So I was having a difficulty in understanding some parts, but half of the part I understood. Like because when I went through these TIFR previous year questions, I saw these types of questions. But when I went for looking for the solutions in YouTube, I couldn't understand it clearly, but now I just got an idea. So when I will get to see this video again, then I think I can prepare it well. So thank you so much for giving this lecture today.
Good evening, sir. I'm Arsha. I'm doing final year BSc B.Ed in Central University of Tamil Nadu. So being a member who joined so late, like maximum 1 month was my time. I started preparing nearly. So the topic is really tough for me. Like I started preparing late, but the tips that you've given were really helpful. And thank you for the time that you have given for us today, sir.
Hello, sir.
Yes.
I'm Iritty. I have done my graduation from Miranda House College, Delhi. The class was really nice, sir. The way you explained everything was clear, and you have included a lot of important points, and that was really useful. Thank you so much.
Yes.
I am Sebastian from Assumption College, Kerala. Many thanks for this wonderful lecture. Thank you for finding your time. The topics were discussed with clarity, and you took your time explaining things. I am a BSc final year student, so it was a bit hard for me, but I am sure it will be useful for me in the future. And thank you, sir. Thank you, Vinod, sir, for conducting this session. Thank you.
So I'm Anamika. I'm from Kerala, Zamaris Western College. The session was really nice, and most important, the all what your presentation and your notes. It was so clear, and it made interest to look about that. I'm a BSc student, so as everybody said, it was a little hard to understand. But it's okay. I think by rewatching this video, I can understand more. Thank you so much for your valuable time.
Thank you. Yeah. Of course. It should be a little bit high, no? Then only you will get the taste of trying. We are making warrior, the process of warrior. You are going to face like strangers, right, in the mid. Lot of strangers will come. In my YouTube channel, there is one trailer I made. It's about how the cyclic groups are getting into some just Hollywood type of trailer I made. You can see that. You can see that idea. What did I made really? I will share this thing in a group. Okay. So you are going to face strangers. So we are making the warriors here so that you can come back and share after some time. After 10 years, you are going to be the one now going to be shared. Right.
In between the lectures, you mentioned about this is the question asked in TIFR interview, CMA interview,
Right.
like that.
You
It was
are asking
really
how do I
helpful.
know?
No. It was really helpful. Like, it would be better if another session separately organized was.
Yes,
So
yes.
please
It
do
would be.
consider about.
The interviews, right? Yeah. I would like to do that. We have to find the timing, and it's not just like me. One of my friends is also, maybe we both maybe together can give this thing. I'm planning. I have a plan about that. Thoroughly interview questions. Since I have a lot of friends who attended interview and it's juniors, they keep sharing their interview experience. So I have a thread of what's going on nowadays, right? So usually in the writing exam, what happens? TFR, I mean NPHM introduce some questions. Those are very new, merely not repeating others. Then this question get low, and it will be like coming in the CSR. Then it will come in the gate and come in the lower exams. Slowly, it's a saturated. Slowly, it will loses the stability, right? So, but in the interview, it's not like that. Interview is based on an individual person. So I still have a very good idea. I will do one or two section about that, definitely. In this
Yeah, Jay, we can plan it. On a later occasion, we can have such sessions.
Yes, definitely.
Is any others? I think we have exhausted almost the time. So I think we can wind up now. So once again, on behalf of the entire team of Math Aspirants, I express my thanks to Jay for being with us, and wish you all the success in your PhD. I hope that you will be coming out with your PhD degree soon. By the next year, I think you will be. I can introduce you as Dr. Jayakumar.
Definitely, I hope so. Definitely.
Yeah. So all the very best. Okay, let us wind up here. Thank you, everyone. Good night.
So I will keep giving some. I'm saying that I will keep give some lectures after, like maybe in a month, once in a month or twice. I will do it. I will talk to sir, and I will make it like a lecture series of something, right? So
Yeah,
so
I
that
think see, one important remarkable point of your lectures is that you are really motivating the students. I think I've seen that it's very interesting. The way of your presenting the things. I think that will be really useful for the students.
upcoming student, of course, this is gone. When it's got from people, it's not from me, but through me. I got
So,
from others.
See, because of this type of initiatives by ourselves, people are getting opportunity to connect people from different institutes. That is also a big achievement, I think. Otherwise, see, students studying in IMSc or IITs may get exposure to different teachers and all that. But here we are trying to provide that type of opportunity, not with exactly faculties, but by upcoming research scholars and young faculty. So I think it will add them something new to their learning experience. Okay, thank you, Jay. Thank you, everyone. Let us wind up here. Good night.
Thank you.
Yeah. Bye.
See you soon. See you also.
Yes.
Thank you, sir, once more.
Yeah.